Hello and welcome to the next OpenUK Future Leaders training session. First, a little about OpenUK Future Leaders Group. The Future Leaders Group is a collection of individuals who are interested in open technologies, including open source software, open hardware, and open data. It includes a wide range of people that work in technology, intellectual property, outsourcing, procurement, data, coding and innovation, as well as private practice lawyers and in-house counsel that work in the technology sector and related fields. It operates under the direction of OpenUK's Legal and Policy Committee and has a clear purpose to bring together and develop future leaders in legal and policy matters relating to open technologies and to support and further the mission of the Legal and Policy Committee. The Future Leaders Group is currently co-chaired by me, Robert Grinnells, and I'm from Phil Fisher, and Katie Gibson from Bristow's, and we're both lawyers advising on technology and commercial matters. The group is always open to new ideas and to new members, whether getting involved in all of our activities or just dipping in and out of our various projects, so please do get in contact if you'd like to be involved. And for today's session, I'm privileged to be joined by Tomas Lamanauskas, who is chair of the OpenUK 5G working group that we're actually launching today, and that Amanda will explain a little bit more about later. Thomas is also the managing partner of Envision Associates and a special advisor for crisis strategy for the Telecommunication Development Bureau of the International Telecommunications Union, the ITU. In these roles, he's been advising on public affairs, public policy, regulatory and strategy goals in telecommunications and digital technology, and also on strategy, activities and stakeholder engagement, especially in response to the COVID-19 crisis that's ongoing. Thomas has more than 20 years of international experience in telecoms and digital policy, regulation and strategy, and his previous career includes positions such as member of the board and CEO, and he's also been Deputy General Director of national telecommunications regulatory authorities in 3 different regions of the world: Eastern Europe, the Middle East and Caribbean. Thomas has also been a senior government advisor on information and communications technology policy in the Pacific, head of corporate strategy at the International Telecommunications Union, as well as the group director of public policy at VEON, a multinational technology and communications company. So we'll have a chance for any questions for Thomas at the end, so please pop them in the chat during the call, and we'll invite you onto voice and video to ask them yourself if you'd like to at the end. Thomas, welcome to our session today, and thanks for joining us. And over to you to talk about 5G and OpenRAN.
Thank you very much, Rob. And I now just got mindful how awful lot word telecommunications appear in my bio, you know. So, but I think that's just the nature of my experience so far. So, thanks very much for this great introduction. And it's the first time I'm introduced as the OpenUK 5G and OpenRAN and OpenRAN working group chair. And I think it's still something that we'll be developing. But, and also, like, thanks very much for joining me today. So I was told, just as a matter of introduction, I was told to assume no prior knowledge on telecommunications in this group. So, you know, apologies for those. And I know there are quite a few of you here who have a lot of knowledge, mostly more knowledge than I on this, on these topics. So, but especially in the beginnings, you'll have to have some patience. But then, of course, hopefully we'll have a great discussion later on as well. So, okay, so where we are. So first of all, just what we'll talk about. So first, and that's what's the initial stage here, we'll talk about key concepts, you know, and why are they, or, you know, then why is OpenRAN in this discussion important, we think. We talk about how open is OpenRAN, you know, so, you know, what is open in it, you know, because I think there's a lot of confusion there. And when we now starting discussing OpenUK, we start realizing that we need to kind of start with the right definitions. What are the players and what is the adoption in this field? So who is playing and how? And then as this is, Rob introduced, you know, I expect in this audience to have quite a few lawyers, you know, so therefore key policy and related legal issues that we would start unravel. We will not end unraveling today, but we'll start unraveling, start identifying today. So, key concepts. So first of all, and as I said, I apologize for those for whom is super basic, you know, but what is 5G? And, you know, because to, you know, when we started talking, what are these generations of mobile telecommunications? So you see here a little bit, you know, a simple picture trying to depict all those now 5 generations of mobile communications technologies that we've had so far. So, and you see, you know, you see that what's I think here important, and really important when we talk further, that roughly every 10 years there is a new mobile telecom technology. And there's also a very interesting other thing that, you know, some of you who are in the industry would notice, that the technologies that we mostly talk about and the most spread are actually every second, you know. So not many people know about 1G, even though I do remember my dad having in his car the huge mobile, like a huge phone with antenna on the top of the car, allowing to, call people on analog, and that was like a rather miracle at that time, that's, and that was like late 80s. But no, I don't think, some people would remember the standards as NMT and so on. However, I don't think a lot of us kind of associate that with revolution of mobile communications. And when it's really started, and when we all know it's in the 90s, is with the 2G, when actually voice communications, and that was 2G about, when voice mobile communications was really popularized, and then late 90s, early 2000s, like basically caused a revolution of adoption. 3G, that actually, so if 2G was and 1G was mainly about voice, 3G started to be about data, but it was, as someone would call bridge technology, and you can see that in the adoption, and you can see that in the fact that now actually one of the technologies that, is most really starts to be retired already, 3G, whereas 2G is here to stick a little bit longer. So it is technology that's introduced us to much more appropriate data speeds on mobile networks. But when it's really good going is with 4G, and that's what we now all again associate our, the successful data mobile communications. That's where we all started using, apps and all the other fancy things when 4G hit. And that's of course also related to the, without marketing specific companies, but also related to the fact that, iPhone also, started popularizing this ability to use mobile for data, not just for voice. And then what we have, so 2G and 1G for about voice, 3G and 4G is about data. So what is 5G about? So 5G is about much more new things. And the challenges here is that I think in many ways, as especially what's happened with 3G, we still start trying to figure out what these new things are about, and what really will be that so-called killer application. I remember when we were, starting to talk about 3G, a lot of articles had this title, what will be the killer application? And then in one shape or form, it's similar discussion starts happening now with the 5G. What is this killer application? Because what 5G in a minute I'll show can do, it can do in theory a lot of things, but we still kind of need to figure out how to monetize that and who want it. And of course, there are some people who think, that could happen similarly as happened with 3G, that 5G will be the bridging technology allowing discovery of new business cases. And what really will get going will be with that 6G, which, if the clock keeps ticking as it used around the early 30s, we should have it. And we already start seeing standardization efforts in that regard, which makes us think that that's pretty realistic. So again, some technical spider chart here, so I'll not try to have too many of those, but you see here a lot of characteristics on what is called IMT 2020, and this is 5G, and what's called IMT Advanced is 4G. It's just the technical terms that's used in international community, especially International Telecommunication Union, to define those different generations of technologies. So you see quite a few things here, but I think in a minute we'll see why a few things are most probably more mentioned at least, and more important for the end users than others. Some others are important more for engineers and techies, like for example, spectrum efficiency. That means that you can cram more data in the same spectrum, which is very important for engineers. But I think for us, when we talk about 5G, we mainly talk about much faster like upload and download speeds. So you see here, as per the standards, up to 20 gigabits per second peak data rate. We talk about latency, and latency is a technical term that means how fast, what's the delay between the signal sent and signal received. So basically, if you want to have, in basic and simple terms, if you want to have a real-time or close to real-time applications, you need a very low latency. And that's why people start talking about, remote surgery, and driverless vehicles, so all those applications that need like immediate reaction. You cannot wait a few seconds before you avoid the collision on a vehicle. And then the other bit, which is also important, what's here called connection density. So that's how devices can be in a certain given square kilometerage or square mileage. So basically here is, that's why we talk about Internet of Things and IoTs. And that's where some of the like a bit more, way of depicting some use cases of 5G are here. So you see, is enhanced mobile broadband, so it's much faster speeds, and that's actually what we now talk a lot when we talk about 5G, about faster speeds. And if you see headlines in most of the newspapers always about, record speeds achieved on 5G. However, the challenge here is it's not clear whether there is a clear use cases, especially on the B2C markets, just for higher speeds. So there are a couple of other, use cases which are now also starting to grab attention, especially in terms of finding use cases as ultra reliable and low latency communication. So it's said like something that needs to be real time or close to real time, and massive machine type communication. So that means Internet of Things. So that means all those vehicles and devices and health tech devices that surround us and are connected and need to be reliably connected. So how fast 5G will grow is kind of anyone's guess, and I guess it's also, again, some of the people would think that 5G most probably would grow slower than 4G, but at the same time we see more optimistic adoption now than we thought we would, Then now the question is, how much of that adoption is real? How much is that adoption just because people have it on their handset, but whether they really use it? But we do see adoption, and just this was March data. These data changes pretty quickly as the technology is not very mature, but you see that's kind of expected at about 20% adoption by the 2025, with Asia, especially developed Asia, leading, and then US, and after that Europe. And in Asia, it's already non-surprising. Like for example, South Korea is really showing very strong adoption there. So just one more thing, techie thing before we go. There will be quite a few actual techie things, but like one here, there, just on the general concepts. Like basically how to read the headlines type of tip. So the two concepts are very often mentioned in a 5G world: the so-called non-standalone 5G, or NSA 5G, and standalone 5G, or SA 5G SA. What's the difference? That non-standalone 5G is built on top of the LTE or fourth generation networks, where standalone has both radio access network and core network independent. I'll quickly talk about what radio access network is in a minute. But what does that mean? That all the benefits of 5G can really be opened up if on a standalone 5G deployments. On non-standalone 5G deployments, there's some benefits are lost because, let's say, the core is not fully ready. It's like having, let's say, very big tap but small pipes, or not big enough pipes, where on the standalone 5G you start building big pipes as well to connect to that tap. So, but of course, because of the cost and investment issues, you definitely would see more initial deployments and more on the non-standalone flavor, and then slowly start standalone flavor being deployed. Again, some of the terminology. So what is radio access network? So radio access network is that piece, that last mile in another way on a mobile network. So in a very non-technical terms, so these is towers, poles, and antennas that sit on them that then communicate with our mobile devices. That radio access network connects to what is called core network. So that is everything where the signals travel within the operator's network, behind that radio access network, and then that connects to the external network of other operators. This is just a more disaggregated and more techier depiction of that, but you'll see in some of the slides this concept of E-node beats and BBUs, baseband units. So this is where we talk about radio access network, and when you see these terms, that's what radio access network is being talked about. So, some concepts. So just to start, so sorry, it's like a little bit like a lecture, but I think it's good to start with. So now, why is it important? So first of all, why we talk about, and some people, especially new to this, would ask why we talk about radio access network specifically on the core network. It's just because radio access network is really big part of the operating investments, and big part, so if you see here, and it's around 60 and coming up to 80% of total capex investments in the equipment is in radio access network, and only 40 to 20% of investments in that regard is in a core network. And that's because radio access network, you need many more base stations and towers and antennas, if you will, and then they connect in a much more scalable or a core network that enjoys economies of scale and all those nice things. So therefore, the issues that we talk, the radio access network is where most opportunities for cost savings are. But also just, we'll not talk a lot about this in this presentation, but just to kind of also maybe anticipating some questions. Yes, there are discussions about open core and virtual core networks, and actually these discussions are much more evolved and much implemented than discussions now about OpenRAN and virtual RAN. So costs, that's the first issue why we talk about this. Another question and issue why we talk about this is the geopolitics, and I think never before the telecoms was so often in geopolitical news and so often discussed by foreign policy gurus as they've been in the last few years, and especially because of what in the US is now called Clean Network Initiative. So Clean Network Initiative is a landmark initiative launched by President Trump's team and spearheaded not even by FCC or Federal Communications Commission, but by Secretary of State Michael Pompeo, which basically, in very simplistic terms, aims to remove Chinese technologies from the networks of the US, but also from the networks of the let's say other countries that support this initiative. And because it's a diplomatic effort, so it's being spread around in the let's say aligned countries as well. So there's lots of discussions, and I think we'll not be talking in this call about the top why it's so, and what are the what is the mix between politics, geopolitics, and security issues and cybersecurity issues that causes discussion. But I think, as a fact, that's been a big force recently, and big force, and because of, and we'll see in a minute why this has been why this big force was impacting actual issues on the ground in telecoms network investments and deployments. And again, as I mentioned, is the U.S. initiative, but it's not only, we've seen impact all over the world, and including most, those of you who followed, you've seen active discussions in the UK, especially beginning and mid this year, which now ended with the decision that, let's say, Chinese vendors should not be bought from, the telecom operators should not procure from Chinese vendors for 5G networks starting from the end of this year, so just over a month left for that, and then technologies there should be removed by 2027. And there is this, and actually that's where I think one of the entry points for OpenUK and why OpenUK should be involved in that, because it's also the task force set to so-called diversify the supply chain in telecommunications vendor market. So that means who we are buying and who telecom operators buying from. So this task force should provide their feedback by the end and their conclusions by the end of this year. Again, not that much left. So why it's so important? Why it's important, these discussions about certain vendors and things? Because as you may see here, the vendor market, the telecoms vendor market, is rather concentrated, and you see 3 players here: Ericsson, Huawei, and Nokia having. And now I should have done my mathematics homework here before, but I think around 75% of the market, as per this, is split between 3 vendors. And 2 of them, let's say, with European origin, and 1 of them with origin from China, and then there are some small emerging vendors. But of course, in this context, you would see that if you're limited 1 vendor or a couple of vendors, the choice is becoming even more limited. So the question is whether the solutions to have more choice, and that's partly what that's in part, or big part, what actually this task force Lord Livingston is looking into. And then another question here is those with a keen eye, you would notice that there's no American companies in this list, and I think that's also felt rather keenly, on the side of the Atlantic that in U.S. leadership in a 5G space, let's say, is not as pronounced as let's say administration and would want and we want to see. So as we mentioned, so there are a couple of forces already mentioned, and which make this debate important. But then the one other forces, so there's basically geopolitics, so the structure of the vendor market. But then there's one other force is that telecoms as an industry hasn't been doing that well over the recent years, actually over the recent decade or so, and the financial pressures are pretty keenly felt by operators. And especially there, and COVID-19 doesn't help, so a lot of people talk about increased use of telecom services during the COVID-19 and rediscovery of telecoms, and especially broadband and mobile broadband, and its importance. But at the same time, it doesn't necessarily translate in revenue upside to the operators. And actually, so let's say IDC, or International Data Corporation, predicts around 1.4% of the decline in telecoms market for this year. At the same time, COVID-19 pressures and lockdowns and the fact that people are moving from the offices to home, so changing use patterns, have also impacted how operators have to use their capex, so have to invest in the networks and reallocate some network spending there, which of course then puts the pressure into investing in new technologies. It's all in the time when 5G is now talked about, and when both politicians and the same industry people would like telecoms to see moving into 5G world. It's at the time when actually financially it's not that easy to do, So, and by other forces I mentioned before, made it not easier. So here is naturally what these three forces do. They clearly say, okay, we need to look for something else. We need to look for other solutions, and we need to at least discover are there any solutions that have a broader vendor space, to have more people to choose from, or vendors to choose from, hopefully that through that competition and hopefully decreasing prices, increasing innovation and speed of deployment and all this other, nice things that we always associate with competition. Of course, trying not to sacrifice other things, like, and we'll talk about some of them, like security, quality of service and other things, and ability also, last but not least, to invest in innovation and new things as established telecom vendors have been doing, so that's where in this context we start talking about OpenRAN. So what is OpenRAN? So now we know what is RAN. So I think now what is radio access network. So now we need to understand what is open. And so open is basically when we talk about open, and we'll talk about in a minute about the features, is basically we talk about ability for different players to provide different parts of the radio access network. Because originally most of that is being integrated into the one vendor. So one of the three major ones or some other ones. Whereas OpenRAN says, can we disaggregate that? Can we provide much broader vendor system? And I didn't put that graph in this slide deck, but yesterday I was looking at this very nice slide that showed how the PC or personal computing industry changed in, let's say, in 80s, and it's also moved from IBM and others integrating everything, in both hardware and software, and providing these integrated systems to work, and then having those different layers being disaggregated from PCs to operating systems to software and all that, and then different players coming into this market and providing different things into it. So that's when we talk about OpenRAN, we're talking about this ability and kind of move to disaggregate the market into much smaller pieces that would together interconnect. And the word open means they can openly interconnect, so that they don't. And in a minute we'll see through which that comes through. So it's just, and I found it useful from one of the slide decks from Mavini, one of the big proponents of OpenRAN and big vendors in this space. This trying to disentangle some of the phrases and terminology that's being used in that context. So OpenRAN is a technology or functionality. ORAN is an industry alliance that promotes this technology, and then VRAN, a virtual RAN, so one of the implementations which is implemented specific architecture, which, like, let's say, virtualized network functions. When we talk about virtualizers, it basically makes the network from a function RAN on different technologies. So you'll see these terms. A lot of people use those terms interchangeably, but they sort of have different meanings. So this is just a very techy, rather techy description from Telecom Infrastructure project that OpenUK is starting to discuss with, what is an OpenRAN architecture. I think what's important here is that all these lines and all these different blocks can actually be now provided by different people, So basically, again, not without needing to understand what the radio unit is, what digital unit is, and what central unit is, the fact is that these units can be provided by different people, that hardware and software can be provided by different people, and that also management and control plane can also be provided by different people. So that means, from the integrated one-box approach, we're now moving to disaggregated, different people providing different pieces approach. So what is OpenRAN in kind of gist? So it's, first of all, when we talk open, and sometimes, this question, what is open about OpenRAN? So the main open thing about OpenRAN is interfaces. That means that this different piece of equipment and different piece of software and the interface between equipment and software, so the different people can plug into this, and provide their things separately, on top of each other or interconnected with each other. So, and what does that mean? That also means, and that's more vRAN's feature, but OpenRAN is working on this. So that the RAN, or radio access network, is becoming increasingly software function. So this is software rather than hardware. And most of the functions, what used to need a dedicated equipment, now can run what's called on commercial off-the-shelf hardware, including so-called x86, processor-based hardware. So that means like our standard PCs, but also, of course, a lot of that is still, is run by other vendors like ARM hardware, ARM processor-based hardware as well. So that's a big change, because if you think, if you can use a standard service, a standard PCs, and to run the network, you're tapping into the market, which is very competitive and had a lot of years of development. So this also, I've already, somewhat mentioned the segregation between software and hardware. So that means that open means that slicing between hardware and software elements, but also slicing generally between different vendors and enables combination of different vendors. In a way, when we talk, if there was a question, can't we have a different vendors before? Yes, we could, and you had operators, let's say, combining in the same network Huawei and Nokia and Ericsson, but usually that would be rather intellectually or very distinct pieces of network. Let's say core, this is a radio access network, so it had a much smaller places where those, let's say, different vendors or smaller interfaces for them to interact and interconnect, and that was much more, let's say, controlled for interoperability. The OpenRAN promises that interoperability is here and is integrated, and you don't need to think about that much, and these different pieces should somehow fit together. And I guess and I'm at the risk of mentioning some names, but I think about OpenRAN versus traditional RAN as you think between Android and iPhone, and also where iPhone is everything integrated on one vendor controls the ecosystem, and the OpenRAN is like Android, where there are different vendors. There's someone produces hardware, someone has software, some people build apps and this, and so everything is rather disaggregated, fully one-to-one comparison, but I think it's close enough. And again, as you would see from this example, there are benefits and drawbacks in both approaches. What OpenRAN is not, and I think it's also sometimes important when we talk about these concepts to understand. So first of all, it's not end-to-end open source. So some people say OpenRAN, immediately think about open source. Yes, and there are some elements of open source that are reused in OpenRAN, so especially because it's run on the x86 machines, so that means you can run on a standardized Linux, and you see then, therefore you see big names like the Linux Foundation and what's been recently starting to call the Open Infrastructure Foundation, or previously OpenStack Foundation. They play a big role in the standardization of different layers of OpenRAN, and a number of other open source players are very active. Let's say Red Hat is a big name in the OpenRAN community. OpenRAN is not again, this maybe the same, it's more or less similar to, it's not an open source. It means that it's not like people here are just there for open source and open source community. So they both reuses the patents of other people who've been there before, including from people like Qualcomm, but also Nokia, Ericsson, and Huawei. But also it creates new intellectual property, and those big names in OpenRAN community actually, creating their own intellectual property that they're trying to monetize as well. However, there are a number of open source initiatives on that are related to RAN, and I'm mentioning a few of them. I'll then cover the whole ecosystem a bit more later. But you see there's OpenUK Interface Software Alliance that tries to look how to use open source for e-interfaces. E-interface is basically the way the mobile phone or like mobile device communicates with a base station that, so basically in simple terms with a tower or antenna on the tower and what sits behind it. So that's piece of the interface. So what software is used there. So OpenUK Interface Software Alliance is looking there, whether you can promote open source in that area. ORAN Software Community Alliance is working, is a collaboration between ORAN Alliance, which is let's say the main industry body for Open RAN promoters, and that works together with the Linux Foundation to see how much and how open source software can be used in RANs. And then TIP, or TIP stands for Telecom Infrastructure Project that I mentioned before, again has different groups just looking how to use open source in Open RAN. But as I say, open source, not all Open RAN is open source, so that's the thing, just important thing. So again, why people like thinking of Open RAN, and just to have it here, this is a slide taken from Open RAN promoters, Mavrini's slide deck, so here of course you see big cost savings, so of course mostly you'll find slides which says that whether they materialize and how they will materialize from people who don't believe in Open RAN that much, but you see here that a lot of discussion here is around cost savings, and then the suggestion that other elements, that means quality of service and others, could match the traditional RAN approach with giving cost savings. And as we discussed before, operators are really keen to find the ways to save costs because of financial pressures and because of the pressure also to deploy 5G as soon as possible without that clear use cases either at this stage. So players and adoption. So what do we talk about here? So here is basically also, I showed you a slide before that showed mobile base station vendor slide, and you saw like 3 main names, and then you saw a few smaller names there. Traditional RAN ecosystem. Of course, it's not very fair because, of course, there are a lot of people who provide elements in that traditional RAN ecosystem, but then there are 3 people who integrate all those elements and sell them together. So here you see a lot of names, and you see a lot of names. Some of them, as I mentioned, familiar for IT people more and even open source community. Some of them are totally new names. Some of them are names that are known in a hardware space, but now reinventing themselves in this Open RAN system. So, and I think what's mostly new here, and a lot of new things here, is the first 2 layers. So system integrators and vRAN software suppliers. So when we talk about Open RAN vendors, again, just some terminology thing, more often than not, we talk about vRAN software suppliers. Because we say that everything, we say, and that's a big stretch, but we do say that everything else is standardized. So these vRAN software suppliers will provide, are the names that actually provide that new source, that new element there. So because, when someone talks about Open RAN vendors, they will talk about Altiostar, Mavenir, Parallel Wireless, and GMA. Now, of course, another base here is system integrators. So why are they important? Because in the traditional RAN, they're not as important because you have one kit, so you don't need to integrate that much. And here you have a big ecosystem, so you do need to integrate. So that's why the system integrators are becoming important in this thing. So the key industry bodies, and you see here, the names. So again, OpenUK, with some of them, OpenUK start working together, and we start interacting. So these are the names that actually work to standardize or to promote and to actually test Open RAN solutions in different aspects of this. So ORAN Alliance is probably the body when someone talks about Open RAN. So that's where promoters gathered together. But then ORAN Alliance has Open RAN Policy Coalition that works closely with OpenRAN Alliance on a policy work, and then together with Linux Foundation, OpenRAN Alliance runs OpenRAN software community. That's again, as I mentioned before, looks into open source, using open source and OpenRAN. And then there are other people like Open Interface that specifically works on interface, air interface piece, and other people that work on a kind of broader things in telecoms ecosystem. So like Telecom Infra Project, very big name in OpenRAN, but they also work in Open Core and other things on equipment standardization, and a lot of other people here as well. But just to kind of throw some names here. Who are adopters? And it's again interesting. So these two names, if you read about OpenRAN, you would hear, first of all, you will hear a lot about Rakuten. And then you will start here quite a bit about Dish, And these are kind of the names of operators. I think a year ago, we'd not even think as a big names in telecom operator community. And Rakuten is a challenger operator in Japan, and Dish is a challenger operator that picked up some spectrum from T-Mobile and Sprint merger, and now launching a new network in the US. And these people say, look, if we were to rethink the network from the scratch, as these operators do, how would we build it? And their answer is we would build with OpenRAN. And that's why, they are huge promoters there. Now, and here is, so it's interesting use case on Rakuten, and there's a lot, lots of people talk about a lot about Rakuten, and I think their chief architecture officer, as they talk, I think he spends as much time in conferences now and talking to other operators as things about internal network, so he's mostly one of the biggest names now in the let's say, technology community of telecoms. But, here is just that there's some principles to mention here that they're building the network based on. So first of all, they build it fully virtualized radio access. So that means, the radio access network for them is software as built as much as possible in standardized equipment. It's OpenRAN, so that means there's different vendors and no black boxes from one vendor. So, and the other bit is which most likely we will not cover in this speech. So edge deployments is a specific architecture that allows them certain amounts of functionality and speeds, and automation, which allows them to save costs by eliminating manual work and increasing speed to market. What's interesting there, and there's another change in this community, that Rakuten is no longer just an adopter, but Rakuten is a promoter. And you see here, that means they no longer just take a technology from vendors and say, now we'll implement this. They actually become the developer of the technology, which they now sell to others, and we'll see in a minute to who as well. And they did quite a few interesting moves in M&A space and partnership space to gear themselves up for that. So Rakuten has what is called Rakuten Communications Platform. That is the standardized platform for radio access network and other network technology that they now not just implementing themselves, but aiming to sell to other operators around the world. To help them achieve that, they actually bought and now fully bought, and they fully own Altiostar. So if you saw, Altiostar was one of the big names, new big names in the OpenRAN ecosystem. And they also got an agreement with one of the big names in the system integrator ecosystem, Tech Mahindra, to actually push for the Rakuten communications platform globally. So it's another interesting angle. So in one way, there's new kids at the block. Another way, the telecom operators also entering this space. Who are the adopters? And I kind of was looking which headline to choose for Vodafone, and then I just opted for this because Vodafone recently had quite a few messages about OpenRAN, both from, let's say, deployment side. So first OpenRAN site for UK, in rural UK, first OpenRAN site in Ireland, joining OpenRAN Policy Coalition, actually setting targets about how much OpenRAN there will be in their network by 2025. A lot of things happening in Vodafone, and it's becoming a big name there. But also Telefonica, and which in UK, of course, is the name behind O2. So is looking strongly into OpenRAN. And that's where, again, another thing comes, which I mentioned, that Rakuten, and that's one of the first discussions that Rakuten announced. So trying to work with Telefonica, not just as a operator partners, but maybe as potential vendor. Interestingly, though, this announcement doesn't include specifically agreement to collaborate on Rakuten's communication platform, but it's broader. But of course, it could lead to Rakuten becoming vendor of choice, or if they prove the technology. So how big will be OpenRAN? So again, its prediction is the thing is always difficult, but ABI research says that around 2028 will be as much OpenRAN as this traditional RAN. And again, some people are more bullish than that. They say like this will be technology that will change now as everyone because it's so new. Some people are very conservative. They say maybe slow deployments, maybe just in rural areas, as Vodafone has done, for example, in the UK. Maybe just by greenfield operators or near greenfield operators, as Rakuten and Dish. But we'll see. But definitely, it's creating a lot of noise, and a lot of people in the community are following it. So the last bit, which is I think is least developed bit, is like a key policy issues. So I've just listed some, and I think that's where I think OpenUK work will be so important, and I think Amanda will talk to that, and I think it will be important to engage with the community here, to tap into everyone's knowledge, start identifying those policy and legal issues, start to see what role OpenUK could play there. But some of the initial lists, like a brainstorming list here is, first is OpenRAN may have an impact on data flows, privacy, and data protection. Just because, for example, in an extreme case, which is not yet fully there, we can have radio access network or RAN deployed on the fully public cloud, And let's say you don't, I haven't found yet such public cloud deployments, examples of public cloud deployments in RAN, but there is an example of core network cloud deployment in the UK where Telefonica Deutschland deployed that. But it's interestingly there, they actually ring fence and they say it will only be hosted in the German cloud, if you will. So that means, because, and they've stated reason to that is the, data protection, data flow issues, and security issues. Interestingly then, that if within the European Union, the operator feels the need to say that, so that means if we talk like outside the European Union, and we only have 1.5 months when UK will be in that list, and then we start talking about the questions as, how broad and how open OpenRAN can be, can we host it, which elements can be hosted on the public cloud, which not, and even when it's not hosted on the public cloud, what are potential data flow, privacy, and data protection issues there. Quality of service issues. So again, it's like a very clear, like a specific regulatory issue, that how quality of service is ensured, but also, of course, it's related closely to commercial technology piece. Can OpenRAN ensure the same levels of quality of service as traditional RAN? Proponents say definitely. The detractors say, and these different elements need to work together. Again, Apple versus Android debate, I guess, for some people. Then the question is, and the related but similar but different question is security. So security means, how secure it will be. And again, two camps there. One camp says, look, vendor who is integrated at all, be it again, Nokia, Ericsson, Huawei, and to some extent Samsung and others, and ZTE, we integrate it all and we control the security, we're responsible for that. Other people say, and I like this, this phrase, I wouldn't now know who to attribute it to, but the phrase was one of the recent events that you can better see cockroaches under the light, So when you have a light shining on it, interfaces, if it's different vendors, you can test and check and see which element is insecure and which element has problems, and if you have bigger community of different people working on that, then again you can see that. Again, for the open source community, it's an interesting debate, like basically Microsoft versus Linux debate in a way you replay, and I'm pretty sure which way this community leans. So, and then licensing and equipment approvals. So basically, telecoms equipment still needs to be licensed. You have many more players in the field, different, or also so-called, at least needs to get so-called type approvals. So again, there'll be interesting regulatory policy issues there. And last but not least, is standardization. So that means, how do we standardize it? Which bodies will do that? And now we have OpenRAN Alliance leading with this, with others, supporting for the different telecom infrastructure project does. But of course, the interesting things, and I had some discussion leading to that. you might have some questions today about like intellectual property protection, especially when you have OpenRAN integrates some standards, some integrate some standards that are pre-OpenRAN standards, and even from the traditional RAN vendors, and related to competition, whether the intellectual property aspects would be used to forestall competition in this race. There's interesting topics that we'll have to uncover. And, so this is just a quote from actually recent Ericsson's blog, which doesn't say OpenRAN is bad, so to kind of, it says that there are risks to take, to think about. And then, of course, some people would take such scheduling as someone being, either as someone being totally conservative, and just being very too careful. Some people will take it as traditional vendors pushing back against new guys on the block and new innovations. Or some of that could take it as legitimate concerns. There's clearly a lot of questions which we'll be able to explore in the near future. But I hope this talk gave a little bit more concepts or insights, let's say, to be able to engage in those questions, and we'll be happy then to use your insights later on in our work that we'll be doing. So thanks a lot, and if there are any questions or any comments, please.
Yes, I think we're opening for questions. I think, John, did you have a question? You want to ask it, or do you want us to ask it?
Yes, I wouldn't see
Katie, while you're finding John, Andrew Back, who's on the call from Line Micro, has been chatting to me about licensing, which Thomas is probably not an expert in open source licensing, but I think he's also got a question for Thomas.
So yeah, just an observation with OpenAir interface. The license for that provides a patent grant for non-commercial use, but OpenAir interface you cannot use in any commercial application unless you enter into FRAND licensing. So I think there's a question there really about the level of openness. Let's say there are alternatives to that. SRS LTE is one that's provided under the Afero GPL, AGPL, so that's maybe closer to what we're used to when we think of open source traditionally. Just one other question though was that so great fan of OpenRAN. I think it's a very exciting wider movement, and ORAN itself is a very welcome move in the right direction. But it does kind of feel to me a little bit like it misses the opportunity in the sense that it feels more like maybe open mainframe interoperability rather than sort of open systems. So you're still looking at radio units with DSPs and it's still built in a very sort of traditional telco way. Whereas so if you were to compare and say, well, how could we replicate what's taken place in the world of computing, then we've moved from mainframes to open systems, distributed computing, commodity hardware, and we use some of that obviously in the core network in OpenRAN, but at the radio side it's still very much built in that sort of traditional way. So just curious as to your thoughts around the opportunity there, in particular software-defined radio and using commodity compute platforms for baseband processing and really up at the radio unit side.
So thanks very much, Andrew, and that's a good point. But I think, just a kind of more broader context, I think in the RAN space, we are at the stage where Microsoft DOS emerged, not when Linux emerged, So that means when kind of software and hardware and different elements started disaggregating, and then open source community emerged that kind of actually made some of those elements into open source and involved much broader community. So I think when I see that now, I think that's the first step is disaggregation. And most probably the second, but that disaggregation, the first disaggregation step allows then for open source community and others to start playing in that space, so to start actually, either on an open hardware or open software side, because that you no longer, let's say, no one is any longer needed if OpenRAN is successful to replicate the whole integrated system. You can actually start on different elements there. And I think that's kind of, again, the back to kind of how, ability to develop Linux. So as I said, so I think this is, it's it's very important it becomes possible. It's not the moment where, let's say, OpenRAN equals open source. So, and that's now is for open source community to see and to identify where it will play. And as you see, there are some movements there, especially because open source key bodies are involved in OpenRAN discussions and development. But it's definitely far from, OpenRAN being equal open source. And I think in a similar way, and discussed like very extensively with some of the other colleagues about like standard essential patents and the FRAND concepts in the OpenRAN space. And we will have those issues, in the very same way as we have the issues, let's say, device or Internet of Things kind of ecosystems. I think what it allows now, though, I think that's why important, again, to qualify in a moment. It's about disaggregating the system and enabling different players now to enter the system. And some of those players, hopefully, will be open source players, but it's not now immediately changing the whole system and how it works.
Thomas, occasionally you break up, just as an FYI. Before we go on, because there are more questions, and interestingly, Rob Pocknell is on the line and wants to talk about SEPs. Before we do that, I'm conscious that we've lost 5 people as we've approached 1 o'clock, and I'm sure you'll run over slightly. I hope you'll run over slightly with the Q&A for us. But I think it's worth just pausing on the point you've made about the open source community and OpenRAN not necessarily equaling open source. And you, a few slides back, identified the existing organizations working in this space. At OpenUK, we've already started to interact with some of the telco organizations, and we're a member of the Linux Foundation, so we will be looking to participate in their activities. So firstly, if anybody who's on this call or anybody who's on this call knows anyone who might like to participate in representing us in those organizations, we will have opportunities for that. So please contact me. In the first instance, probably me on that one. Jamie Harper, our head of partnerships, is also working on that. So Jamie would also be worth contacting. The second thing I wanted to talk about was that we are in fact launching today with Thomas chairing, as Rob Grenell's mentioned at the beginning of this session, a new policy group within OpenUK focusing on 5G and other telco matters. 1 or 2 of the people on the call have already committed to be part of that group, and I hope that a number of others will. So please, we will be sharing it this afternoon on social media with the video of this recording from today. I hope you will take the time to join us and help shape that policy work that we do around making OpenRAN open source. We may even have the ability to help influence and change that across the globe, not just in the UK. And there are a number of you on this call who I know are really steeped in that environment and could bring a lot to this. So I really hope you will join us. Thomas, do you want to add anything about that work group?
No, I think for now, as you say, Amanda, it's great. Would be great to have people, people who are interested in this work on it, And then I think, as you most likely noticed from this presentation, there's a lot of ocean to be boiled, And I, of course, I can only bring a little bit to it, but I think hopefully we'll have a group that has like all this diversity of expertise and experience that we can, first of all, as we discussed, identify the issues to be addressed, because I think that's already the big work. And then once we identify the issues to be addressed, and where OpenUK could add value to this ecosystem, then working to create that value. And I think that's we're only starting it, and hopefully the ones who are as excited as I and what's happening and these new things that's happening in telecoms and this, like they say, intersection now that telecoms is becoming more and more IT in a way, so I think, those people who are excited about that, I think would be great to have in this group and to start discussing what's important, how we can contribute.
Many of us have watched that move in the telco sector to the whole sort of software-defined networking over the last few years, and I know people like John who want to ask you a question now are very into the whole edge piece, and that's all going to be relevant to this too. I think there's an amalgamation of a number of different things that are happening that create the future. John, Robert, you both want to ask questions. Do you want to jump in and do those now before we wrap up?
You talking about John Laban?
Who else? Hello. Hello, John.
Hello.
Hi, John.
Hello, Thomas. Well done. Really good presentation. Fantastic. Now, there's another chap on this call called Steve Helvey, and something that you mentioned these other organisations like TIP and ONF, and we're very keen to get TIP and ONF more actively involved. And Steve is the liaison person from the Open Compute project with TIP and ONF. I don't know whether Steve's there and he could come in and help on this.
John, Steve had to drop off.
Okay.
We've just joined TIP. It's one of the organisations that we've joined, and Thomas and I have had our first call with them, and we're just working out exactly where we can get involved and offer most support to them.
Okay, well, just to let you know that. But coming back to one thing that you mentioned right at the beginning, Thomas, the question was about the energy. You showed that wonderful spider chart, and you showed, I think it was about 100-fold reduction in energy as you move to 5G. Now, I've got kind of an understanding of that, but there's a lot of talk in the media that as we move to 5G, there's going to be this huge surge in energy consumption. Could you sort of cover that point?
So, John, and I'm not like I'm not an engineer or expert on that, but like you see that. But the thing with 5G, one thing can speculate is, first of all, 5G is you need much more dense equipment for 5G, because one thing with 5G is, especially if you move to the high speeds, you need so-called, again, trying to simplify that, but you need different spectrum bands to be used. Some of the spectrum bands are called millimeter wave spectrum bands. So for those in engineering, 26 to 28 gigahertz spectrum bands. So that means they're much shorter radio frequencies. What that means, you need more equipment. It provides faster speeds but shorter distances. So you'll hear a lot in this 5G space, way more than you heard in 4G space. Concepts like small cells, and small cells means like a very low coverage, like radio devices that basically connect to the base station, and they are located everywhere, in different places. And you'll hear a lot of these words called network densification, so that you need more equipment for 5G to be there. So I think the problem is when we talk about network energy efficiency, it's way more efficient for piece of equipment. It's way more efficient per data being transferred, but it's just much more equipment and much more data being transferred. So I think that's where we have, and I think we can do. So I think that's the biggest challenge on. So I think if we were to use 5G exactly the same way as we use 4G, it would be way more efficient. But the problem is that we don't use it that way because it allows us more. So that's why it's. That's why that's why energy efficiency is there, and I think that's still a big road to travel, to try to kind of, to try to resolve that piece. And I don't think it's just a network efficiency will be the solution, but it will be renewable energy piece, so kind of trying to use that, and like innovative solutions, because like small sets into lampposts can have solar panels on them, so how to use that to power some of the small cell deployments. So lots of other thinking needs to be done there, and just a core technology in itself cannot resolve it.
Thanks.
Robert, are you there? Do you want to ask your question on SEPs?
I think we've lost Robert. I think he's had to drop off.
So, Robert, I'm just finding it.
Can John Laban ask another question?
Yes.
Thomas, you mentioned something about when you started to discuss Rakuten and about the way they're becoming involved with the design of the products that they use. It's a term that we've kind of had in the hyperscale cloud service provider space. We call them prosumers, that they actually get involved with the design of the products. So there's a kind of a switch that really changes the emphasis on how efficient equipment becomes. Could you kind of take that up? And it's just that what I'm seeing in the telco space is I'm seeing a development of prosumers, professional consumers that get involved in design in the telco space, similar to what I've seen in the hyperscale, and they just seem to be copying the trend. Any comments?
First of all, I think this copying the trend is not accidental. If you look at Rakuten's stated strategies, they specifically want people from the IT kind of digital platforms and hyperscale space, when they hire engineers. So they don't hire, like it used to be the time when telecoms operators would not hire commercial people from telecoms, would want commercial people from FMCG. Now telecoms people hire engineers, not from telecoms, but from hyperscalers, and I think they bring with that their own approaches, both to engineering, but also to collaborating with vendors. And if you look, and it's a very good case study in Rakuten done by a TM Forum, that so-called, and it includes this piece called no RFP approach. So that Rakuten doesn't work through RFPs, And now TM Forum talks about that quite a bit. That means they don't they don't believe anymore that you can specify everything and go out to the market. They believe that you need to especially in this fast evolving market where technologies are not just being developed, you need to go and talk to vendors and ask them what can they do for you, rather than ask them to do what you think you want, and then work with vendors to see how that would work in your network and how you can extract most value from them. I think in a way it's a very good approach because it opens up more value. I think it's another way is just a sign how things are not as standardized as maybe they used to be, because it's just much more difficult to do RFP, and the kind of ecosystem moves much faster. And if you want to capture the innovation, you can no longer say these are the requirements. You have to say, tell me what you can do for me, But I think so that's definitely the move. And you see people like Rakuten and potential Dish and others who are new to the space. They're not just moving there; they're starting there, And I hope other telecom operators are slowly starting to follow. But I think Rakuten goes further, and not only Rakuten. If you look at people like Reliance Jio, and again, there is a coincidence there because the Armin, the chief architecture officer, comes from Jio, to Rakuten. So the people are not only becoming prosumers, they're becoming vendor-sumers, So they build a thing they don't just collaborate with the vendors, they actually build a thing that then use and then they sell it to others, So again, the question is whether it's a long-term strategy or is a strategy, let's say, to enable technology development. But you clearly see that, clearly see Rakuten at least betting on this, and it could be, and I'm now my wild guess, that Rakuten in the years to come will earn more of being a vendor and will use Japan as a showcase or a place to showcase the technology rather than, other way around, rather than building technology for themselves. Of course, the jury is out there, but definitely they're having these, in very integrated and feedback loop supported approach where they build a network in Japan and in parallel they build the technology for their own network, but also for other people's networks. So I guess in that way, they're more than prosumers now.
Thomas, I think what's really interesting to me as an ex-lawyer from software and what you just said is that 10 years ago, we were going through this challenge of moving from a waterfall structure to an agile one where you move from specifying what you wanted to specifying the governance that you would use as you developed and innovated collaboratively. And it sounds like that's something that the open software sector can give a lot back to the telcos as they move forward. Just to wrap up, we've got one final question. Now, Rob Pocknell, who I think is going to join our 5G work group, has had to drop off the call, and he's got quite a long question in the chat. We don't have a lot of time left, but in short, I think he's asking, do you expect we will see a lot more litigation in the patent space because of OpenRAN and SEPs, particularly in the SEP space? And it will be interesting to see because we also have Open Invention Network protecting us in the open source space, and a number of the network packages are already in that definition. So perhaps that's something our work group will look at.
So my short answer is, and not being an expert in this industry, yes, just because they're enabling, there's enabling environment for more litigation, and I guess that's a good news for lawyers because simply more people means less abilities to agree and more abilities to kind of sue each other, And so that's A. Then B is there's definitely a clear kind of tension being set up between, like, say, traditional technologies and the new technologies, and these new technologies are not emerging in a green field; they are kind of being built up on existing technologies. So presumably there will be quite a few of the existing technology being integrated in this, and this creates the opportunity, let's say, from some players from traditional technology space to try to capture or regain some value through intellectual properties, to claiming their intellectual property rights. And then, of course, new people in this. There's a lot of new people in this space who are now developing intellectual property, and who hope to be valued highly, you know, in this space. And they're already going to IPOs. Some people wouldn't mention names, just tried and go back for different reasons from IPO. This piece of the, you know, trying now to go public and extract some valuations there is also will be more important. And as you go public and try to extract valuations, so first you want to protect your intellectual property, but also other people, you become a target for other people to try to get some piece of the game, you know. So I definitely think it's exciting times for lawyers who want to get in that space.
That seems a very good note to end on. So thank you so much again, Thomas, for your really interesting talk. And next week we've got Armin Hemmel talking about containers and everything we need to know. So hopefully see some of you there next week.
Katie, I'm just going to jump in there on that container talk. There's actually a Linux Foundation paper on the way to manage legal issues in containerization, which Armin, as a technical expert, is one of the co-authors of. For anybody who is dealing with risk and legal issues and trying to understand what containerization really means, that talk next week is going to be absolutely excellent, and I highly recommend it.